Welcome to a session on acid, bases, and salts. So today we want to look at the acids. So I'm sure we've come across the word acid. For example, the fluid in a battery. Yeah, especially those secondary batteries like a battery for a vehicle. They mostly contain sulfuric acid and it serves a purpose there. So what is an acid? An acid can be said to be a proton donor. That is a simple definition. Now, if they say it is a proton donor, meaning when something is charged positively, we know that a positive particle is a proton. So an acid always, when it reacts with a particular thing, it gives out hydrogen ions. So this is the reason why it is called a proton donor. Another definition is an acid is a substance which when dissolved in water or aqueous solution, it produces hydrogen ion as the only positively charged particle. That is another definition for acids. Now, types of acids. We have two types of acids. The first one is strong acids, and the other name for strong acids are amino or organic acids. Now, what are these acids? Strong acids are acids like hydrochloric acid, nitric acid, sulfuric acid. Now, what happens is if either of these acids was to dissolve in water or aqueous, this hydrogen ion you are seeing here, it completely ionizes. That's why it is called a strong acid. So strong acids are acids that completely ionizes when dissolved in aqueous. Then what about weak acids? These are acids that partially ionizes when dissolved in aqueous solution or water. And the example that we have is methanoic acids, ethanoic acids, carbonic acids. Another example are all those organic acids. They qualify to be weak acids. What do we mean when we say basicity of an acid, this word? We know that when an acid dissolves in water, there's a certain number of moles of hydrogen ions that are being produced. So, how many moles of hydrogen ions are produced from 1 mole of an acid? That is what we mean by basicity of an acid. So, this is what you should know about an acid. Then, what are the physical characteristics? How can you tell this is an acid? It has a sour taste. I'm sure you've tasted an orange before or a lemon. A lemon has an acid, acetic acid in there, or citric acid, sorry. It has citric acid there. Now, the acid there, it's a little bit sour in orange than in lemon. In lemon, there's a lot of sour taste there. So that's what you should know. They have sour taste. They also turn a blue litmus paper red, meaning that when you get a litmus paper, it's just a small paper which is blue, you put it in acid, it will turn red. Then you tell that this substance that I have is an acid. Acid have also the potential hydrogen less than 7. What you should know is that the pH ranges from 1 to 14. So meaning that below 7 there, below 7 is on the middle, 0 then 14. So this side are acid, this side are bases or alkalis. So below 7, the pH is for acids. What are the chemical characteristics of acids? The way acid behaves, see, when we say chemical characteristics, we mean any acid behave the same way. When an acid reacts with metals, especially reactive metals, they give two things out, a salt and hydrogen gas only. So this is a key concept. Whenever question has come on acid reacting with metals, you expect the product to be a salt and hydrogen gas. So look at this example. Sodium react with hydrochloric acid. The product is sodium chloride, which is a salt, and hydrogen gas. Acid also react with bases and alkalis. In future, we shall learn the difference between a base and alkali. And when they react, they form salt and water only. And this reaction is called the neutralization reaction because an alkali here or a base neutralizes the acid. An example we have, this is an alkali. All metal hydroxide are alkali. So we have sodium hydroxide plus sulfuric acid. It gives us a salt, sodium sulfate, and water only. Very key concept. The last chemical characteristics is when acid react with metal carbonates or hydrogen carbonates, they give three things. Number one, salt, water, and carbon dioxide. This happens when acids react with metal carbonate or hydrogen carbonate. Calcium carbonate plus sulfuric acid gives us calcium sulfate, water, and the carbon dioxide. Meaning any metal carbonate, that's how it behaves. Thank you for watching. We meet next time when we talk about alkali or bases.